Today we are going to work on our second way to solve systems of equations, which is elimination. Now remember, the solution to a system of equations is simply that point on the ordered pair where those two lines intersect or where they cross. So the best way to use the elimination is when both equations are in standard form. Remember, standard form is when your x and your y is on one side of the equal sign and on the other side is a number. We used the substitution method when we had at least one of them in slope-intercept form, or at least a y equal or an x equal. So for this one, it works best when both of them are in standard form. So here's our first example. We have the line 2x plus 3y equals 20. And we have the line negative 2x plus y equals 4. So we're going to go ahead and find where these two lines cross on our coordinate grid, which of course the answer is going to be an xy ordered pair. So here are our steps. Now our first step is to make one of the variables the opposite of a variable in the other equation. Now what that means is the opposite of 5 is negative 5. The opposite of 12 is negative 12. So we want our coefficients of an x or the coefficients of the y to be opposites of each other. Now this is a sometimes step because sometimes it's already done for us. So in this case, we can see that it's already done because we have a 2x and a negative 2x. So 2x and negative 2x are opposites of each other. Now, when we have that first one taken care of, and we're going to have some examples so we can see what we do when they're not already set up that way, we're going to go ahead and we're going to add these two equations together. So 2x plus negative 2x goes away. 3y plus y is 4y, and 20 plus 4 is 24. So we have 4y is equal to 24. Now we're going to go ahead and simply solve for our remaining variables. So we're going to divide both sides by 4, and that leaves us with y is equal to 6. So we're going to go ahead and set up our answer, which we know is an ordered pair with our x first and our y second. And we're going to put our 6 in that second position. So now we're going to go ahead and do what we did back in our substitution method as well. We know that y is 6, so we're going to pick either one of the two equations, and we're going to go ahead and solve for x now that we know that y is 6. I'm going to go ahead and choose that second equation, negative 2x plus y equals 4, because it doesn't really matter which one you choose. So you will get the same answer regardless if you choose the top equation or the bottom equation. I chose this one because the numbers are a little bit smaller. So we're going to go ahead and plug in 6 in place of y. Negative 2x plus 6 equals 4. And we are solving. Subtract 6 from both sides. Negative 2x is equal to negative 2. And x is equal to positive 1. So now we're going to go ahead and put that in our x position of our ordered pair. And we now know that these two cross at the point 1, 6. Now, just like before, once we get our answer, there's two ways to solve. We can plug them both in both of the original equations and make sure both of them are true. So here we have 2 plus 18 equals 20. That's true. And we have negative 2 plus 6 is equal to 4. So that's correct. Our other option here that we can do is we can go ahead and point them both on the graphing calculator and look at that point where they intersect. And as you can see, they do indeed intersect at the point 1, 6. Okay, let's go ahead and look at a second example. Here we have 2x minus y equals 10 and 4x plus y equals 8. So once again, that first step is already done for us. We have a negative y and a y, and those are opposites of each other. So we're going to jump in and just add them together. So 2x plus 4x is 6x. The y and negative y cancel out, and 10 plus 8 equals 18. So we're going to go ahead and divide both sides by 6. And of course, we have x is equal to 3. We go ahead and set up our answer, and we put our 3 in the x position. Now we're going to go ahead and plug that into either one of the top equations and solve for y. So I'm going to go ahead and pick 4x plus y equals 8 because y is already isolated, so that'll save me the division step. So 4 times 3, because we now know that x is 3, plus y equals 8. 12 plus y equals 8. Subtract 12 from both sides, and y is equal to negative 4. Once again, we can now check by either plugging both x and y into our equation, making sure they both make true statements, or using Desmos. Here I have positive 6 minus negative 4 equals 10 for that top equation. And then we have 12 plus negative 4 equals 8 for the second equation. And those are both true statements. Okay, now we're going to go ahead and bump up that level of difficulty for our final example, example 3. In this example, we are going to have to do that first step. And we're going to work more on this for our next class as well. But as you can see, I have a 3x and a 2x. Those aren't opposites. And I have a negative 2y and a 4y. Those aren't opposites. So one of the ways to decide what we're going to do to change it is I can see I do have a negative and a positive. I have a negative 2y and a positive 4y. And I know that I can multiply the entire top equation on both sides by 2, and that would make that a negative 4y, which would make it opposite of the 4y from the second equation. So we're going to go ahead and do that. Now remember, we're going to use the distributive property, and we have to remember to make sure we multiply every single term on both sides. So 2 times 3x becomes 6x. 2 times negative 2y equals negative 4y, and 2 times 4 equals 8. So as you can see in blue here, all I've done is simply multiplied every single term on both sides by 2. However, now we have that first step taken care of. We have a 4y and a negative 4y. So make sure you remember to multiply it by every term on both sides. A lot of people forget to do it on the other side of the equation as well, and that would give you a different line. So now we're going to go ahead, and with our new equation, we're going to go ahead and add those together. So 2x and 6x make 8x. The y's cancel out. 8 plus 8 is 16. So we have 8x equals 16. Now all we have to do is divide both sides by 8, and we get x is equal to 2. We set up our answer and put 2 in our x position. Now we're going to go ahead and plug it in once again, either of the equations, and solve for y. So I'm going to go ahead and use that second equation, 2x plus 4y equals 8. I now know that x is 2, so we have 2 times 2 plus 4y equals 8, which 2 times 2 is 4, so 4 plus 4y equals 8. Subtract 4 from both sides. 4y equals 4. Divide both sides by 4. And finally, we know our y is equal to 1. We plug that in our 1 position. Now, when we're checking here, we should always go back to our original equations. In this case, our 2 equations are orange. So we have 3 times 2 is 6, and 6 minus 2 is 4. And our second equation, 2 times 2 is 4, and 4 plus 4 is 8. So we know that we're correct because it made both of the original equations true. Now we're going to practice this, of course, in Desmos, and in next class, we're going to work on even harder ones where we're not multiplying just one of the equations, but both. Once again, this is how to use the elimination method to solve and find the solution of a system of equations, which is the point where 2 equations cross.